Hello everyone, and thank you for attending today's webinar, exploring real-world 5G use cases at the 5G Open Innovation Lab, sponsored by Amdocs. Before we begin, I wanted to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide decks are available for download in the green Resource List widget. Towards the end of today's presentation, please complete the survey that is on the right-hand side of your screen. It will only take 1 minute to complete, and your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I'd now like to turn the event over to Heavy Readings Analyst at Large, Simon Stanley.
Hello and welcome from me as well. Now, I'm joined today by three speakers. First of all, we have Jim Brzmitzis, who is founder and CEO at the 5G Open Innovation Lab. Jim, perhaps you could just tell us a little about yourself and the 5G Innovation Lab.
Certainly, Simon. Thank you very much for the introduction and for allowing me to be part of today's webinar. So my name is Jim Brzmitzis. I'm the founder of the 5G Open Innovation Lab. Prior to founding the lab in 2019, I'd been at Microsoft for almost 14 years, and before that, Oracle, PeopleSoft, and I started my career at Nortel Networks. So I've been very much in the software industry for my entire career. And I saw a really interesting opportunity in 5G relative to where enterprises and digital transformation were going, and also in connecting the software ecosystem to this broad ecosystem of 5G. And we'll talk a little bit more about that today.
Great. Thanks very much, Jim. And next we have Ron Porter, who is head of 5G network and OSS product marketing at Amdocs. Ron, perhaps tell us a little about yourself and also Amdocs.
Thanks, Simon. Well, Amdocs, as you know, is a software and services solution provider to service providers all around the world. Today, we're going to be focusing mostly on angles of 5G, obviously complementing what Jim discussed in the 5G Open Innovation Lab. Naturally, we're involved in many trials and POCs exploring the new potential of 5G, specifically 5G standalone. And we're very happy to participate in the 5G Open Innovation Lab and actually trying and bringing to life some use cases, which we plan to show today, as well as some additional partners like Dirk, who will be introduced just after me.
Great. Thanks very much, Ron. And as Ron said, we're also joined by Dirk Schau, who is co-founder and CEO at Taqtile. Dirk, perhaps you could tell us about Taqtile.
Sure. Thanks, Simon, and thank you as well for inviting us to join this session here. Taqtile is focused on building the most comprehensive AR work instruction platform, specifically targeted towards industrial users. So we've been working in the head-mounted augmented reality or spatial computing space for about 7 years. And we have a very interesting and comprehensive sort of approach to how you enable industrial workers using this technology, a typically very underserved portion of the population when it comes to technology solutions.
Great, sounds interesting. Thanks, Dirk. And we're going to start today's webinar with Jim, who is going to be talking about the 5G Open Innovation Lab, covering mission, ecosystem, and use cases. Next, Ron will take a look at some implemented success stories covering both the key benefits and the key KPIs achieved. And then we'll finish with Dirk, who's going to discuss how AR applications leverage the dynamic network to speed up complex procedures. At the end, there'll be a Q&A session, so please do send in any questions you have for our speakers as we go through. So with that, I'm going to hand over to Jim.
Get off the mute button. Thank you, Simon. Again, I appreciate that. Yeah, I'm back. So everyone, when we looked at 5G, there was really two ways of looking at the opportunity. The connectivity play obviously is a huge opportunity, and we're anticipating, just like everyone else in the world, that 5G will play a pretty transformative role both in our consumer and our enterprise lives. But we also looked at it from the standpoint of how can carriers really increase their share of wallet? And the best way to really do that is to line closer and closer as you can to the software industry and the ecosystem. What I discovered back in 2018 when I started digging deeper into the standards for 5G was that there really wasn't a center of gravity of a software ecosystem. And so we set out to really start to build some of that capability to really bring a lot of these to life. So when we think about what our mission is for the 5G Open Innovation Lab, it's really about that intersection of innovation and platforms and industry coming together. I'll go into a little bit more of that in just a moment, but when we focused on this opportunity, we really focus on the enterprise as really the biggest benefactors of 5G, and we think of 5G as really connectivity and edge computing. The enterprises today, according to Gartner, will spend somewhere between $3.4 to $3.6 trillion. IDC had initially forecasted their digital transformation journey investments being $2.8 trillion, and in late 2021 actually bumped that forecast up almost 2 times to $6.8 trillion. So there's a tremendous amount of money being spent in the marketplace that's really software driven, but enabled by critical connectivity. In the enterprise as well, there's a lot of interest today around private wireless networking. We've all seen it. Number of enterprises that I've had a chance to speak with are actually making some early bets and moving in that direction, and they're doing so because a lot of their digital transformation efforts really require that. In fact, we're working on a few opportunities of our own where connectivity is a critical enabler. Not the destination, but certainly a critical enabler. So our program is very much focused on the enterprise and very much focused around digital transformation. And we get to work with teams like Dirk from Tactile, but 58 other teams and 13 more that are starting with us in March that are all building capabilities and use cases that are digitally transformative in opportunity that really require, again, that connectivity and computing on the edge. Our program is not an accelerator or an incubator by any stretch. The teams that we've worked with, including Dirk's, really don't need acceleration or not necessarily apt to going after an incubator program. So we get to see teams that are really of all stages. We get to see seed stage teams to companies that we'll talk about a little later today, like Proximi or Juganu out of Tel Aviv that have raised north of $70 million. We're a no equity, no fee program. We're entirely funded through our partnerships. And that leads us to our next piece. One of the biggest lessons that I had learned at my almost 14 years at Microsoft is that by leading with partners, actually scale faster. And so our program initially started off with founding partnerships that included Intel and T-Mobile, and since we've grown it out to an additional 12 partners, 14 in total, and we're adding a few more that we'll be announcing in March and a few others that will be announced later this year. These partners are critical not just because of the financial commitment they made to the program, but they're super critical because they unlock a number of opportunities for the teams that we work with, and vice versa. Our teams are unlocking a number of opportunities for these partners as well. Now, my early discussions with T-Mobile as one of our first founding partners, we had talked at length about the opportunity of 5G and edge computing and all the other fun stuff, but what I had recognized even back then was there are other major ecosystem players that have deep roots in the enterprise, in hybrid and cloud computing, have strong interests in where edge computing is, and have active developer engagements in the software ecosystem. So in building out the spirit of the lab, we ended up really engaging with a number of other partners in this ecosystem that are quite important. Intel is an example, Microsoft, Accenture, and Avanade, Ericsson and Nokia, and the list goes on. These are all critical and partners because in any given market, there isn't a single enterprise that onto its own is its own ecosystem. In many cases, these enterprises are supported by a fairly broad set of ecosystem players. And in the case of where we believe the 5G opportunity and edge computing opportunity is, this couldn't be further from the truth. And so from our standpoint, when we were really building out the program and the partnership model and attracting key teams, it was really important for us to really bring a broad set of enterprise-minded ecosystems to the table. We were very fortunate last year on announcing our first industry partnership with C&H Industries. If you're not familiar with C&H, they are the makers of heavy equipment. They do so under brands like Case and New Holland. They're moving digital in a very big way. And at some point, they believe that farming and agriculture operations, including even construction and other verticals, will likely rely heavily on capabilities like machine learning and computer vision and AI. They believe very strongly that automation is going to play a much bigger role in their solutions going forward. And for them, they really wanted to get access to not just the technologies that our partners bring to bear in this space, but also to work with a set of innovators in the startups that we engage in and have engaged in to learn more about how to augment their efforts. All this to say, over the last 2 and a bit years, we've had the fortune of bringing 59 teams into our program. And as I mentioned earlier, they really range from pre-seed to Series A to through Series C teams. In total, each of the teams combined have raised $272 million of pre-program funding. $522 million of pre-program funding, over $272 million of post-program fundraising. That's a really important statistics because it demonstrates the strength of the teams that we're able to attract into the program and the success that they've had post-program as well. As of our fifth batch, will start here on March 7th. It's very likely we're going to cross over the $1 billion of total valuation. So as I mentioned earlier, this is not an incubator or acceleration program. It's very much an enterprise-minded program that focuses on that intersection of industry, innovation, and platforms working together. Now, many people ask, what are some of the killer use cases? Is there a silver bullet of use cases for 5G? And the reality is, I don't think there's just one. I think there's many. And so we did a selection of just a small number of our teams and pulled together some use cases that are in play today. This morning, I had an opportunity to catch up with Nadine Haram. She is the founder and CEO of Proximy, that use case at the top of the middle column there. They've gone on to raise an additional $37 million in Series B. And she was mentioning that, I won't name names just for confidentiality's sake, but she is working with an MNO internationally who is using Proximy as a key use case to break into the hospital and healthcare networks. And what they're finding is that Proximy helps to solve that very important surgical problem that most surgeons, including Nadine, who herself is a surgeon, in trying to tap expertise from other surgeons from around the world while they're in surgery using augmented reality. A very similar use case you're going to hear from Dirk on the frontline workers spot in just a minute. But they're using Proximy as a way to demonstrate real value, and then as Proximy is creating value in those surgical instances, they're actually seeing hospitals being much more open to replacing their wireless strategy, in some cases going private 4G LTE or private 5G as well. And so, as she said, Proximy is helping to create a bit of a wedge for this MNO globally to actually access into and bring more connectivity and in some cases even compute capabilities as well. The other use cases here are really interesting use cases that are really in some cases testing the boundaries of connectivity, one of which is a use case that's been highly publicized. It involves Halo, which was part of our first batch alongside with Dirk and T-Mobile. Halo provides an autonomous car service currently piloting in Las Vegas here in the United States. Back at CES in early January, they were the pole car that led the autonomous vehicle challenge. The car reached over 90 plus miles per hour. The vehicles on that track were doing well over 200 miles an hour. And their car, the Halo car, was absolutely remotely navigated. There was nobody in the vehicle at that time. And that really pushes the boundaries. Think about a 2,000-pound vehicle that's hurtling through the world today with nobody in it and completely operated autonomously from a remote station. That really pushes the performance of the network. And then we have others that you're welcome to look to. The last one I would love to point out is Expedo, that we've also had a chance to work with from our first batch. They are the underlining capabilities for Rogers' private wireless networking offering through Rogers Business. And they announced a little while ago that they've lit up a site with Kirkland Lakes Gold in Canada. Kirkland Lake Gold is the second largest producer of gold in the world, and they've gone entirely to a wireless strategy using Rogers Spectrum and Expeto as an underlying platform. So these are all really interesting use cases, and they're interesting in two ways. One, they fundamentally, in some cases, are changing the way that service providers are selling into the enterprise. And two, in many cases, they're exposing service providers to a much bigger share of wallet opportunity, and that is really on the compute side that's really nested in the software ecosystem. And that's exactly what we've very much focused on. Now, as part of our own journey, we here in our own space are setting up our own 5G lab, and it will be a melting pot of technologies, both from all of our partners, but also all of our startups. And the goal in doing so is very similar to the goal that we had in setting up our 2 agricultural-based field labs in Snohomish County. So we're here in Seattle, and just north of us is the town of Snohomish. North of that is the town of Arlington, and we have 2 operating CBRS-based but 5G-capable networks that are running today. And we set up those networks because we really want to understand, if we were our own service provider, what would it mean to open up our networks so that application providers like a Dirk from Taqtile or others could not only use the network for its connectivity, but also use the network for its compute capacity. Both of those networks have dedicated edge computing nodes as well. I don't want to steal too much more of Ron's thunder, who's going to come up and talk about some of those use cases that we've explored together. But what you'll see is that if you stop at connectivity in the case of 5G, you're actually limiting yourself in terms of the major opportunities that go beyond that. And here at the 5G Open Innovation Lab, we had that key question of what could you do more with connectivity, and it really came down to bringing that software ecosystem together with connectivity on really exploring what those opportunities are. And so with that, Ron, I'd like to introduce you and have you kind of walk through some of the use cases that we collaborated together on at the farms.
Thanks a lot, Jim. And it's great to hear. And really, you know, Amdocs, we're involved in multiple POCs, exploring 5G, and especially looking into 5G standalone. And looking into it, you know, with service providers, from operational perspectives, how it will work to implement a slice and end-to-end orchestration, and from monetization perspectives, right? How will the BSS, the business support systems, interact with these new dynamic networks, dynamic services? How will you charge and bill and monetize, and the user interaction? So many things have to be working together. And I think the cool thing in the 5G Open Innovation Lab is the focus on the use case. And you showed a wide range of use cases, and we'll start with the story of Amdocs and Apples, which is focused on the agriculture use case. But again, it's just a proof of how we are linking business requirements and application requirements and user requirements down to the underlying network, and being able to stitch it together and adjust it, make it work, make the service or the application or the enterprise get specifically what they need from the dynamic network, right? Be a specific slice or an edge resource or a specific density, right? Or any of these 5G currencies that we have to really bring value. And I think this is one of the key things here, that by implementing already a first use case, we're already starting to see actual value. And this is part of what we wanted to show here. So like Jim mentioned, the story here is talking about agriculture and, you know, making agriculture amazing, harnessing the power of 5G to maximize yields of the crops. But also, you know, there's an environmental angle to this story, as we'll see, because one of the benefits in the use case was a significant save to water usage. So again, like was mentioned, we're talking about a Washington State farm, and we have a drone that is going up. Well, actually, it's a set of drones, multiple drones going up over the field to take 4K resolutions, pictures from across the fields. Now, the goal here is to get this scanning going out throughout a very, very, you know, large, you know, the farms areas are huge, right? So you cannot really go and do this manually. So having the drones going above the entire fields and taking 4K images provides in-depth knowledge and inputs to the farmer. Now, that's not 5G related necessarily, but typically you would have to put up these drones, send them out, bring them back, get the footage out manually, then start to analyze it, maybe locally, maybe uploaded it to the public cloud. But again, many of these farms are remote, so how do you get it in there? So a main goal here was to really streamline and orchestrate this end-to-end service. So again, we have this, our farmer going out at 7 in the morning, sending out the drones to take out this pictures resolution. There's a private network deployed across the farm and a localized edge at the nearby barn. So the pictures are transferred over the private network to the localized edge, where a significant amount of a processing can be done on premise. So again, by this we get the benefit of dramatically reducing the amount of data we have to send up to the cloud. So the edge handles a lot of the stitching of the network, of the pictures together, and doing the compressing and actually uploading a 3D model to the public cloud. Now, naturally, this requires some application to be deployed at the edge. And again, if we're talking about a larger scale, so not just one farm, but dozens of farms, maybe even hundreds of farms, you would not want, right, all of these applications to constantly be everywhere, right? You want to have a much more on-demand approach. So once the farmer launched the application, we'll be deploying what's needed at the edge to do the stitching, send the appropriate information to the public cloud. In this case, it's in Azure public cloud, and the connectivity from the private network to there is over T-Mobile network. And then the images are processed in the public cloud in Microsoft Azure by a startup called Innovate, which is very much focused on analysis of agricultural data, right? And in this case, it's coming from drones, but it can also combine inputs from various IoT sensors throughout the fields using advanced algorithms and machine learning. And again, they have the benefit of being targeted for the agriculture use case, but we see the specific needs for the connectivity and from the network resources to implement it and make this happen in real time. So all of this processing happened in the cloud, and then within minutes, the actual insights can be sent directly back to the farmer so he can see, and we're seeing some real images that of the project here, actionable insights on their, in this case, the apple orchard, but of course it's not limited to a specific crop, right? So where do you need more irrigation or fertilizers or pesticides or density or any of these other decisions? And again, think about the size and magnitude of these farms. So sending out multiple drones across and not having to start downloading and doing all this manual processing to do the analysis. Because again, the application in itself, if you think, right, is something that does exist. The key thing here is this, from the click to making it happen throughout the network, across a private network, edge resources, cloud analytics, and back to the user engagement. And like I mentioned before, to me, the attractive thing here, and Dirk mentioned before, looking for the silver bullet or the killer 5G use case, and it's not about one, right? It's about having multiple different use cases, and we saw a bunch of examples. But here we're seeing how one example being implemented proper is translated to immediate KPIs, right? So increasing crop yields, reducing water usage by 50%. So that's huge. Think of the amount of water that is used. So 50% here is a dramatic improvement. Getting better visibility to the state of the crop, to where you need to apply the water, etc., and building a better tomorrow by the water saving, etc. And again, the main benefit that was showcased here is a process that would potentially take days, because these are terabytes of data, and how do you do it and manage it? And now it's done in a few minutes in the very digital real-time engagement that we know. And we're all aware that, right, that when things don't work like that in today's day and age, they won't succeed, right? We want to have the result and the ability to interact with things in this digital real-time manner. We're used to doing that with the public cloud, but now we're extending it all the way across the network. So what's Amdocs play, I think, in this use case? And in general, when we talk about 5G use cases, we're very much focused on enabling this network automation and monetization. So it's kind of two pillars to really leverage the 5G network. So it starts from allocating dedicated resources for the dynamic needs, right? Things like placing the application where it's needed, or maybe even orchestrating network resources themselves. It's in this case, slicing hasn't been implemented, but we do imagine that in future, when we will have a 5G core on premise, we might have different slices for different applications, maybe inside the private network, maybe connecting to a public network. So all of that is around more the operational angle. Doing and monitoring and assurance of the quality of the experience that's needed. Again, each service or each different startup or application might have different requirements, and you will want to assure them. Obviously, Jim talked about the driverless cars. Obviously, a driverless car will have a very, very strict SLA that you'll want to keep to make sure things are going as needed and you're getting the monitoring in real time. And let's not forget, right, the monetization, right? At the end of the day, for 5G to succeed, we need to find the business model. And this business model, so not only the operational paradigm is new, the monetization paradigm is new. How do you monetize these services? How do you charge for them, right? It's not the traditional monthly plans that service providers are used to work with, and not even traditional enterprise B2B business models, because things now can be much more based as on-demand models, based on usage, and maybe adopting some business models we are familiar with that are used in the public cloud. But again, now they can be extended to the 5G network. And again, Amdocs solutions range from orchestrating and automating 5G slices and edge end-to-end, because the connectivity goes, we saw here, connectivity goes from private network through the edge, up to the public cloud and back to the user. Having closed loop operations, self-healing and scaling in case you suddenly have, maybe in a farm, you won't have load, but if you think of things like stadiums where suddenly you have masses of people come in and you want to scale up your network resources and then scale them down when people have left. And having a unified common inventory, so one single source of truth, so you know exactly what's happening in the network. The network is now dynamic. The services are dynamic. It's not the static connectivity environment that we knew from the previous generations. Having everything to be much more dynamic, you need the single pane of glass to see what's happening. And on the other end, the monetization, right? How do you monetize this dynamic resource allocation, these dynamic services? It touches to areas of Amdocs, our 5G value plane, offering things around charging and policy that have to work very tightly coupled together, right? Charging is how you count the usage and rate it, and policy is what different services can get. Again, everything as was configured. And NWDAF is a network data analytics function. So again, we need enhanced analytics from across the network. And the NEF network exposure function about exposing APIs. Because the use case we just saw, it might be directly to a farmer and to dozens of farmers, but it might also be to a farming company that handles dozens of farms, or a solution provider. So it'll be like a B2B2C model. So that solution provider might want to be able to access the network and see the performance in real time and interact with it through APIs. So there's a whole world of possibilities that can be done here. And again, all these type of labs is exactly where we are exploring and proving how this would work. And this is another way of what I discussed before, the wide range of solutions. And again, Amdocs Role implemented this use case. So from the deployment, the rollout, so rolling out the private network, doing the radio planning and the actual rollout and integration and the edge deployment, the design. And design time is both the network design, how do I design the network, stitch together the different network components for the end-to-end network service, and the service itself and what it includes. The commercial offer definition, again, when this would be monetized, how do I offer it? How do I charge for it? Who is able to see these type of offers? The digital engagement, right? How the user will see this, or how maybe it's a partner portal that will want to activate the various network slices. So how the engagement come, and once he clicks on it, the dynamic network and service orchestration. So once I got the user engagement, how do I make the service happen? How do I make the network resources available? So everything we saw on those cool slides over PowerPoint, of course, it has to happen in real life, right? Orchestrating the application to the edge, making the connectivity, having the analysis in the cloud, and coming back over the different types of connectivity. I mentioned before the network analytics and the assurance, so making sure I keep giving the service what it needs, the SLA that it bought. Might be latency, it might be the reliability or the density or the coverage, on and on and on. And at the end, talking about charging and policy, which also I mentioned before, for the innovative monetization models, right? How do I charge for this? How do I enable the new business models and this new world of possibilities because, and this goes back to what Jim showed before, we are not talking about the drone analytics use case at the farm, because the first people to react will say, no, I already know drones, and I don't believe agriculture is a 5G use case, and we're not talking about that, right? Even at the farm itself, already today, right? So we see here a few of the different partners that were involved in the first use case, and this is the top one, right? Getting the analytics from the drone and IoT sensors and having it processed in the public cloud by Innovate, which is one of the companies within the 5G Open Innovation Lab ecosystem. But the next use case is actually being implemented in these days, and this is a use case involving Taqtile. And Dirk I'll hand over to him in a minute or two. So once again, the use case is around having assisted maintenance, right? If a tractor is breaking out in the middle of the field, the fact that I don't have to send out a trained technician, but I can have this AR assisted maintenance that guides him how to change the oil or how to fix this problem, of course, translates into ROI. But this AR application has different needs than the application of the analytics of the drone. And the next use case at the farm will be around video surveillance and identifying movement of people, because in this case, it's a farm that also has tourists, and might be also security, and their cameras have different requirements. So stitching the specific network resources and performance to each one of these services, or to the intent of these services, is exactly what we came here to do and prove. And like we saw, it's not just about a farm, because the next use case we're exploring together with a 5G Open Innovation Lab is around the port use case. And some of these applications will be relevant there, but again, the requirements will be different. So again, it's very exciting times, and helping to, right? It's a big ecosystem, a lot of moving parts, a lot of stuff has to happen so it can be streamlined and really deliver on the promise of 5G we've been hearing for a long time now. And I think part of what we want to try and show here is we're starting to see the fruits. It's not going to happen tomorrow, having a click and an autonomous tractor taking the fields, and everything happened fully automated. But we're advancing there and helping our partners finding the best way to implement these solutions. So like I mentioned, we saw here the first use case around drones and analytics of agriculture, and the second use case being implemented these days is around Taqtile. So I think it's a great handoff to Dirk.
Thank you so much, Ron, and appreciate that. Great insight. I learned something during your talk as well, and thank you, Jim, for your comments earlier. Augmented reality is something that I think that we're hearing a lot of lately. There's a lot of excitement about some of the upcoming platforms that are coming out, but this technology has been in use for quite some time in training, for example, but also in some early examples of how augmented reality in the hands of a deskless worker can enable them to do things that they weren't capable of doing, without this technology previously. To just talk about how we fit into this whole 5G ecosystem, as always, if the network is the piping, the applications are the water, right? And when you look at the capability of the piping out there, prior to 5G, for example, you have, maybe this is good enough for things like, some lower quality video, it's good for downloading, etc. But if you're talking about augmented reality that involves things like spatial computing and involves things like holograms, like multi-user real live chat in industrial and potentially dangerous environments trying to solve problems, well, all of a sudden, just like the Halo car example that Jim used, you have serious implications for things going wrong. And so at that point, when you want to think about how you deploy this technology in the real world, in real hardcore applications, you need to start with the network, and it needs to have bandwidth, low latency, all of these great things that are inherent. So just to talk a little bit about how big a problem or problem/opportunity this really is. Something around 80% of all workers globally are deskless workers, right? So these are people that do not sit behind a computer when they do their job. These are people that work in factories. These are people that work in restaurants. They're also people that do surgeries, right? When a surgeon is not sitting behind a computer when they're operating. So how do you sort of think about enabling them from a digital perspective in the same way that knowledge workers have been enabled? And although there's a huge number of workers in this space, you also have this tsunami of workers that are either aging out of the workforce or they're voluntarily leaving the workforce. And so you have this real big brain drain of information about these highly complex environments that's leaving the market at the largest pace that has ever occurred. And so, the challenge really is, how do you capture their knowledge and how do you enable or undertrained workers to do jobs as if they were an expert? There are huge downsides to untrained workers in the workforce. I believe that on average, when a manufacturer goes down, they're spending somewhere around $200,000 per hour across large and small manufacturers when there's downtime. So if you have an untrained person working on a piece of equipment and they mess something up, and the line goes down, that can be an emergency situation. Now, on top of this problem of finding sort of skilled workers, you also have this problem, or you have an opportunity here where frontline workers, deskless workers, believe that technology would improve their performance. These workers, especially younger workers who at home are, playing games on high-powered gaming PCs, they're messing around with all sorts of other augmented technology as well. And then they come into a workforce and there's nothing there that sort of leads them to the future. That anyone can see that is a gap. And so this technology sort of really offers this sort of digital transformation. The analogy that I like to use is that, 25 years ago, the desktop worker, our lives were transformed by things like office suites or productivity suites, right? Those things are not used on the front line. What do frontline workers need to do? They need to create checklists, access checklists, collaborate with other workers, right? And the best way to do this is through a headset right now. The industries that are heavily involved in evaluating this from an industrial perspective, everything from defense, manufacturing, logistics. These are big things. You think about a company, let's say like FedEx, for example. Think about how large their fleet is and how often that fleet may break down, or how often that they need to do maintenance on these pieces of equipment. Like, these are massive problems that need real world solutions to be solved. Pharmaceutical, for example, how do you train someone in a lab environment to do something? How do you bring on new workers as fast as possible with the confidence that you are going to be able to that they're going to do things according to your policy, safety, all that sort of thing. And I'll talk about specifically about the a use case here momentarily, but the value proposition for this type of technology is literally across the board. Let's start with safety, right? When you walk into an industrial organization of any sort, the first thing that you see is a sign above the door that says, hey, it's been 100 days since our last accident. Let's stay safe out there. So number one, safety is job number one. And if you can reduce your error rate or eliminate your error rate from 92% of errors in untrained workers, it comes from a study from the U.S. Air Force, completely eliminating those errors, well, you're going to make a much safer environment. But you have all these other benefits, such as reduction of error and scrap, more accurate inspections. Inspection is a big use case for this as well. So, travel support costs, right? So what if I am a manufacturer of a highly specialized piece of equipment, and there's only a few people in the world that know how to work on this or maintain it? Well, if I have to send those skilled workers on a plane every day or every week to go fix something on the other side of the world, those workers are going to get burned out, number one. Number two, your customers are going to have a substantial lag in sort of the quality of the experience they have with you, and it's increasingly more expensive. So what if you could have a remote expert basically almost transport themselves into the location where their customer is using their product, and have the customer sort of like guide the customer through this operational or maintenance process? This is just like a huge benefit. So benefits are all over the board in this area using this technology. It's a huge opportunity here, as we said. I'll just flip past that right to the sort of the punchline here. So what are the capabilities of 5G that we really use, right? So the ability to download information, the ability to connect with people remotely in a real robust manner. What if I am a utility worker and I am on top of a pole in a storm and I'm trying to connect with someone that's going to help me do something? If I have 720p video versus 4K video, that's a big improvement, right? 5G represents the opportunity to do that in the field, right? And on demand. Reduction of latency. When you're downloading a hologram to use in this sort of an environment, you also need that to happen very quickly. The ability to connect a whole bunch of sensors and people at the same time. So if you have, if your implementation of your equipment out there in field involves a lot of IoT and a lot of collaboration among multiple workers, this is a real opportunity for 5G as well. So all across the board, there's a whole lot of different opportunities. Quick use case, and then I'll pass it back to Simon here. There's a company in the Midwest using our technology. There's a number of companies that sort of work in the augmented reality industrial technology space as well. This company, PBC Linear, this is a small manufacturer, and they've had real problems retaining and maintaining workers just because of the challenges that all manufacturers are having right now: competition, pay, the fact that our infrastructure that used to have a lot of this sort of apprentice infrastructure built into it, that is sort of that's showing up in our rearview mirror at this point, right? So how you get people up and running very quickly. This company, PBC Linear, converted their whole operation into augmented reality processes where they captured every machine and how you operate those, how you maintain them, how you repair them. And so now when someone comes into the plant, they just put their headset on and they start going. And this allows them to hire a different profile of worker. It also allows them to focus on different things when they're onboarding those workers. So I think I may have run over a little bit on my time. I'm going to pass it back to Simon, and I think we're going to move into some questions. Thank you.
Okay, thanks very much, Dirk. And indeed, yes, we are now going to the Q&A session. We've had some really good questions come in, but if you've got any more questions for our speakers, please do send those in. I think I'm perhaps going to run a couple of questions together and go to Ron first. And Ron, if you want to pass it on to one of the other speakers, that would be great. So the two questions here are, does this assume the customer has their own spectrum, or are they using public spectrum? And also, what level of CapEx is required at the base level to deploy these types of B2B use case solutions?
So I think, yeah, it's an interesting question. And so, I mean, to start off, it depends, right? I think like Jim mentioned here, you know, one of the initial implementations is over CBRS spectrum. And at least in the US, CBRS spectrum is a big opportunity. It does allow, you know, deployments of private networks and how to work with that and implement that. In other areas of the world, spectrum, again, depends. Some countries do have industrial spectrum that can be made available for use. And in other more advanced scenarios, you can consider spectrum being an additional currency that a service provider might want to allocate, right? Or it might even be a combination, right? You might have your own initial use cases based on monitoring, which do fine with shared spectrum, right? Again, CBRS in the United States. And then when you need suddenly a boost of performance for a very demanding application where that public shared spectrum is not enough or it's not reliable enough, you might again tap into some spectrum allocation from the service provider. And of course, another angle to that is really, and that when we will have 5G standalone and things like slicing comes into play, so potentially you may be able to have your own private environment based on a public slice, and then you don't need to handle on slices. You don't need to rely on the private network on the spectrum issues, but it's part of the what you will be acquiring from the service provider. And that, I think, directly connects to the, you asked about the CapEx, the investment. So, right, deploying your own radio network has some physical investment alongside some of the benefits. On the other end, using something that's more based and sourced out by the service provider and is more dynamic or more in an on-demand model, right? So you don't have to invest that yourself, but you are in a different engagement with the service provider. So I think it really comes back to what we said all along, the requirements of the specific use cases and the benefit in having it dynamic so you can optimize what you use yourself. But last sentence is, you know, to me, an analogy would be compared to the public cloud, right? The benefits of having stuff in the public cloud or where you're hosting locally and you know, on your own data center and what you balance it out for various considerations. And at the end of the day, we're seeing as the public cloud evolved, right? Every enterprise found the balance of how they want to, you know, work between the two options. But Jim, if you want to expand on that, I'll be happy.
Yeah, we I think that's a great answer, Ron. We're also seeing in other industries. So, for instance, here in the Seattle area, we're heavily involved with the Tacoma Tide Flats. The Tacoma Tide Flats is the location of the largest part of the largest port operations here in the Pacific Northwest. And you know, there is a clear case where CBRS or unlicensed spectrum plays a role. There are many clear cases where licensed spectrum plays a role as well. And I think for carriers, they have a tremendous asset in their spectrum inventory. There's an interesting world that's evolving both in private enterprise networking where they provide the direct solution, but in larger industrial areas like a port system or other similar areas, there's a really interesting approach here that we're seeing build out. And of course, we're in the early innings of this effort today. There was a question similarly so asked around the CapEx build out costs for this. And really the best answer is it depends. In many cases, the two farms that we operate are slightly overbuilt, and that was purposeful because we wanted to really explore what it would mean to bring connectivity and computing into a single, to sort of a single instance and learn from that. But in many cases, you don't necessarily need to build out that much capability. What we're seeing is once we've unlocked that connectivity, Ron had mentioned one of our teams called Innovate Ag. They use LiDAR scanning for scanning tree fruit row crops. It's just a small acreage of land, about 5 acres or so, that they do that LiDAR scanning of, and soil sensing as well. In each pass for 5 acres generates north of 10 terabytes of data. Now today, Steve Mantle, who's the founder, will load his side-by-side up with all that LiDAR equipment into a trailer. That trailer actually has its own dedicated data center. He's running an Azure Stack Edge. So while he's traveling to the next farm, he's actually unloading the data and processing it, and then where he can get connectivity, uploading the processed data to the Azure instance that he's running today. That's the extent of where people have to go to actually drive that innovation. Our farms represent an opportunity to, as Ron shared with the drone, offload that data real time, process it right on site, because you don't need to move massive amounts of data to public cloud instances. You could process a lot of that data much closer to where it's being generated and only move the relevant data up to a cloud application. And that's a really interesting opportunity for us as well. I think, again, it lends itself to giving the service providers a different opportunity to monetize, and in doing so, actually create stronger engagements with the software ecosystem.
I'd just like to add also on the CapEx side, from a software application layer perspective, many, if not most, of the applications at this point can be had using a SaaS model. So you typically pay a fairly low monthly fee on this. So this typically can be considered an OpEx expense. And it's actually, it tends to be fairly low to really be able to get into some advanced applications that really can support that and can leverage the new network infrastructure to do things that you weren't able to do before.
Okay, great. So some good answers there. I want to go to this next question. I'll start with Jim, and then perhaps if anybody else wants to come in. So the question is, what has been the initial reaction from the agriculture industry on the willingness to use 5G or AI to improve their processes?
Actually, quite positive. You have to realize most of these agricultural sites are really in the rural areas of civilization, so they rarely have any connectivity, if at any. And by helping to expose these two growers to some connectivity, it wasn't just the fact that they now had connectivity and they can do stuff. It actually unlocked application potential, like Dirk from Tactile or Innovate Ag or Blue White Robotics, another team that we've had the privilege to work with at the 5G Open Innovation Lab doing autonomous tractors and such. It unlocks that entire ecosystem that we all take for granted when we live in our urban settings, because we have that access. For these growers and in other industries who are also equally as so located in rural areas of whatever countries they're operating in, they don't have that access to that type of innovation, and so therefore they're very much regulated to to what means of innovation they do have. That's changing. Here in the United States, we about a year and a half ago started opening up the unlicensed spectrum space called CBRS, which we've talked at length about. And one of the biggest bidders, if you go through the auction and look at it from June of 2020, one of the biggest bidders on the private sector side was actually Chevron. Chevron was actually buying a lot of CBRS spectrum, priority spectrum, around some of the sites where they're refining and producing oil and oil products. And that's because they need to actually bring their operations into a digitally transformed new way. And they recognize the way for them to do that was to unlock the potential of creating data, harvesting that data, processing that data on site so that their operations can be a lot more efficient. And we're starting to see that actually happen around the world. And in fact, I believe it was BMW and Mercedes and ThyssenKrupp and other private players actually were pretty active in bidding for spectrum in Germany as well in 2020. So the enterprise is going to be moving forward on this digital transformation journey. COVID-19 is actually, it shook the world markets, but in many cases, if you talk to service integrators or systems integrators like an Accenture or Augmented here that work with us in the lab, many enterprises took the opportunity of COVID-19 to build resiliency into their operations. And so they started doubling down on their adoption of technology. Most of that technology, again, needs connectivity, and an increasing share of that new technology or the use cases really relies on computing on the edge, far, far away from where they have computing today. And that's ballooning the $6.8 trillion in forecasted digital transformation spending that IDC has claimed late last year.
Okay, does anyone else want to add to that?
I just wanted to say again, to me, it's just about a little bit, to make a little bit of an old movie quote, right? If you build it, they will come. If the value is there, right, they'll adopt it. If they can save money, save water, and more efficient working, right? If you're in the manufacturing, a factory a car manufacturing factory, if he can produce 10 more cars a day, right? The ROI writes itself out. And the main benefits we come to show here is that you don't have to buy everything upfront and install everything and have it. So you have Dirk talked about a SaaS model for the application, and we're seeing much more of an on-demand kind of business model for these different industries. So that really is going to enable much more these innovative use cases, and as they emerge, because many of the technologies are already there, it's just more how do we make it operate at scale and make it cost efficient. So yeah, we're going to monetize it, but in a way that it can be very widespread.
Okay, great. Well, I think we've probably got room for one or two more questions. So I want to actually run a couple of questions together and again go to Jim first, and then if anyone else wants to come in. So the first question is, are there any use cases in automotive? And then the second one is, can you expand on the use cases you were talking about with health and hospital vertical use cases and the requirements for 5G and MEC?
Yeah, on the automotive side, there's essentially two, and they're quite obvious. So there are no lightning rods here of insight. But the first is around the connected car experience. We're seeing Tesla really drive a lot of that, but also Volkswagen, BMW, Mercedes, General Motors, others are really moving towards embedding more and more experiences via connected car. On the manufacturing side, we actually had a chance to speak with several robotic startups that are working quite closely with the manufacturers on the automotive side, and what they're seeing is what we're seeing as well. Manufacturing generally is taking a long, hard look at private 4G LTE, private 5G networks as a way for their digital transformation journeys. And for robotics, that's highly relatable, because in many cases in the automotive space, they're constantly changing manufacturing lines and processes. And when you have wired connections for some of these robotics, it becomes very cumbersome, very slow to be agile. And so those are the two big areas that we have seen. There's likely more that we'll be seeing as well. On the healthcare side, yeah, please. Sorry,
just in auto, just density of sensors, just these facilities are massive, and if you can eliminate wiring or augment that with a solid network, connecting devices, visualization of big assets. There's a lot of CAD that goes on there. So we see a lot of adoption of this technology in automotive.
And just to connect to that, sorry, Joe, just to throw in, again, we were involved with a North American carrier around a POC focusing on a healthcare use case. And again, it touches to, we saw that we don't have time for everything, but there were questions about private networks and versus the public service provider, how this whole balance worked out. But again, the use case there was you might have a private network or dedicated coverage for the hospital itself, for example, that can be supporting a wide range of different applications, right? So medical equipment that needs this type of performance, or just handling data records locally, or public internet for people coming up. But what the interesting use case there was also adding some remote access based on a public slide. So for example, if you need an expert to monitor remotely and have some access to have assisted remote surgery, not necessarily that he'll be operating, but maybe even seeing and diagnosing remotely and getting this remote dedicated connectivity. Again, this is an area where the service providers have a benefit, and another thing that they can monetize because they have the wide area coverage and the scalability to support this, and extending these use cases beyond just the localized application.
So does anybody else want to come in on the health use case?
For healthcare, there's a number of different use cases. The one that I mentioned earlier with Proximy, and they're a Series B stage company, was really, really interesting. They're very much seeing themselves as being a wedge, a reason for a carrier in this case to actually lead with an application, being Proximy, as a way for them to deepen their relationship inside these hospital systems. And as they're, what Nadine was sharing with me this morning, as they continue to deploy more and more Proximy, they see that it's actually opening up bigger discussions with these healthcare providers, hospitals specifically, around rethinking their wireless strategy. Look, every industry around the world today is a data industry. It doesn't matter if you're producing vehicles or you're in the healthcare space or you're producing steel. Anything you do is a data play. These 5G networks are very, very important because they reach that data. Now, embedding the compute capacity in that for a service provider not only helps you to monetize more of your own services, it gives you a much deeper relationship both in the enterprise world and also in the startup world. And those two efforts, the enterprise and the startup ecosystem and all the platforms around it, are going to move forward regardless. They're glacial in their size. They're just moving forward. And so for me, the whole opportunity around 5G wasn't just about how our worlds will be much faster and more enriched because of the fantastic capabilities of these networks. For me, this was an opportunity for the carrier industry and the industry at large to actually have a much more meaningful relationship with the software industry, the same software industry in the 4G LTE world that generated trillions of dollars on top of these networks, for which many of the carriers really didn't have a chance to participate in. And 5G was and is that really interesting pivot point where you can start to really make those changes because the networks themselves are becoming cloudified. And that's really, really important. For the enterprises, they're going to be they're making bets today. I anticipate that will increase over time. I think IDC's estimate is in the ballpark of where it's going to be in terms of how much they're spending in digital transformation. And this window right now that exists is an important one to really explore. So the closer you are to the software ecosystem, the greater the opportunity is. And we're starting to see that really in spades from our standpoint.
Just one last word on that. One last word is the fact that, one of the things about 5G, it's been hyped for so many years that many people are now thinking, right, it's already here. Where is the, where's all the cool stuff? And I think now is the time where the radio is out there, starting to go into 5G standalone, cloudified networks. So now is the really time. Different operators are starting to explore within their systems and labs like this. Right, so it's the time where we're starting to get our hands dirty and really bring these things to life, and I think that's why it's really an exciting time how things will develop.
Okay, great. Well, I'm afraid we have actually run out of time. Some really good questions. Thanks for sending those in, and I'd just like to thank our speakers today: Jim from the 5G Open Innovation Lab, Ron from Amdocs, and Dirk from Tactile, and myself, Simon Stanley. Thanks for your time, and have a great day.
Thank you.